So I've just put the solution up there. I think everyone pretty much got it right. Some people without any help at all, which was really good. Does anyone need me to go through it? The basic idea was that the energy requirements are pretty much the same as the energy output, and it's within the appetite limit, so it all fits. And then I think you were supposed to go on and consider, well, what happens, you know, the cows have got a reproductive problem on this farm, what else might it be? And I've suggested maybe something like estrus detection would be a problem on the farm. So I think you all got the hang of calculating the feed energy. These ones here, the feed energy from each of the components. A few people forgot to multiply by the dry matter content, but got it in the end. And then calculating the energy for maintenance. That was just on the table. Then the energy for production, which is 25 times the energy content of the milk. That threw a few people, but got it in the end. And then important to subtract a negative value for the live weight loss. So that's a contribution, leading to 169 and 169. So it all fitted. Okay. Now there is another exercise there if you want to do it in your own time. You've all got the solutions. There's also a mineral rationing exercise, and we can talk more about that later if we want, but we're beginning to run out of time a little bit. Any questions on what we've done so far? Okay, let's talk about protein. We're not going to do a protein rationing exercise. It gets pretty complicated. Usually they're calculated on the computers, and I wanted really just to talk to you about protein rationing. But protein rationing is really important because protein is much more expensive than energy. Okay, and also there's a strong relationship between protein intake and a lot of the metabolic disorders, particularly reproductive disorders and lameness. So when cows are fed inadequate amounts of protein, then they begin to get these metabolic disorders. And also, there's quite a high cost to the environment of nitrogen losses. So in some European countries, there are now audits of the farms for two components, and that's nitrogen and phosphorus. Potentially causing damage to the waterways, so it's really important to control the outputs. Just a bit of the history. A little bit of history. Protein rationing was originally done quite simply about 100 years ago, using something called the biological value of the protein, which is the percentage of the truly digestible nitrogen that was used for maintenance, growth, milk, and pregnancy. So a little bit the same idea as the metabolizable energy system, which I dealt with before lunch. In the protein system, it's taking each individual component and saying how much protein does the animal need for that. That was replaced by the DCP, or digestible crude protein system, which ran for many years, a very workable system, and it was based on feeding experiments, but it is actually the digestible protein. But in the 1980s, when cows were beginning to give a lot more milk, and the reason for that, in Europe at least, after the Second World War, there was a lot of concern that countries were not self-sufficient for food production. And that had threatened the livelihood of people in the United Kingdom, in France, wherever, because the importation of foods was very difficult in the Second World War. So after the war, it took some time for animal production systems to intensify, But with government support through the 1960s and 70s, animal production systems did intensify. We saw a lot of intensive housing systems develop, the battery cage for chickens, the farrowing crate for pigs. And the culmination of that with milking cows was that by the end of the 1970s, milking cows were, in Europe, a lot of them were being fed about 3 tons of concentrates every year. They were producing 7,000 or 8,000 litres. The genetics weren't very good at that time. And there was massive amounts of fertilizer going onto the grassland. So it was all a sort of, you know, a bicycle that was going faster and faster and faster. And the farmers were having to constantly produce more and more milk to make a profit. And there was a vast surplus of milk. This is the irony, a vast surplus of milk in the European community, as it then was. And the reason this is related to rationing is because scientists began to realize that this DCP system wasn't very good. You needed to take into account how much protein was being absorbed from the rumen and then how much was being absorbed from the small intestine, because the cow gets its protein requirements from 2 sources. Firstly, the rumen digestion, and then the microorganisms pass to the small intestine. They are digested by peptidases, and then that protein is absorbed. That nitrogen is absorbed. But also you've got the protein which bypasses the rumen, goes into the small intestine, is digested, and is absorbed directly. So 2 sources began to be realized. So it then became realized that the tissue protein requirements were met by the rumen degradable protein, corrected for efficiency factors, and the undegraded protein, also corrected for efficiency factors. Some of the problems associated with these sort of calculations were that the protein utilization would depend to some extent on the feed intake. If the feed intake is very high and everything is going through the gut quickly, then the digestibility of the protein in the rumen is lower. So that isn't taken into account. Also, that if there's a vast surplus of rumen degradable protein, supposing you're feeding a lot of urea, a nitrogen-rich compound, with straw, as you do, and that goes into the rumen, there's actually a cost of detoxifying that urea. So the urea is all absorbed into the bloodstream, and it's expensive for the animal to detoxify it. Thirdly, it is assuming that the amino acids are in the right proportions. And they may not be. Some feeds may be deficient in some amino acids, a bit like with chicken feeding. Does anyone know which feeds are typically deficient in chicken feed? What amino acids? Lysine. And methionine, yes. And methionine has also been added to cattle diets with some good effect. So methionine, particularly in maize, I think it is tending to be deficient. So this is assuming that the amino acids are in the right proportions and assuming that we know the degradabilities of the feeds. For those of you that are scientifically oriented, and I think most of you are, there are problems with determining the degradability. How do we do that? Anyone know how? We'll put it in a Dacron bag, insert it into the rumen, and then see how much is left after a certain period of time. And there's a lot of inaccuracies to that. The food isn't able to move around the rumen as it normally would, and the rumen functions quite differently at the top, where there's a raft of grass material compared with the bottom. So pretty inaccurate. So knowing the feed degradability is a real problem. And some of the feeds, if you take, for example, Brewer's grains, do you have that? You have that one? Brewer's waste grains from brewing.
Yeah,
Yeah? What do you call it? I'm sure you have it.
Not much. As in,
Okay, no one drinks beer.
but they're not so widely established.
It's not used for feeding cattle? Okay. In many parts of the world it's used for feeding cattle. And the point of my mentioning it is that the protein in brewer's grains is naturally protected, but some of it is protected so much that it doesn't get digested at all. So it may be wasted. Okay, that's what I was looking for. The problems associated with this determination of degradability of the feed in Dacron bags, a whole set of problems attached to it. Particles will come into the bag as well as going out, maybe selective degradation of the feed, and there are some alternative methods. Incubating feedstuffs in rumen liquor obtained from an abattoir. Is anyone working with gas production techniques for feed evaluation? Okay, well you can evaluate the feed quite simply if you put the feed in a test tube and add rumen liquor on top of it, and you look at the rate of gas production. So you can use that to look at, say, the influence of toxic compounds on feed digestion. We've done that with lead. You add lead to the grass, typical of what you would get from the cars, and you see that the degradation of the grass goes right down. The gas production is reduced. And then we can use near-infrared spectroscopy, NIRS. That has become increasingly used. It's sensing the color of the grass, and there's some very good equations now to relate that to the chemical composition. So things are improving. This bag insertion is quite commonly used in ruminant research. Another one of the problems is that if we look at changes over the day, then some of the nitrogen will be wasted. And it's, as I was saying, it's costly for the animal to detoxify that. So here's the rumen ammonia concentration. As the nitrogenous compounds are volatilized into ammonia, and that's absorbed into the bloodstream. But these are this is the absorption rate. Some of it will be wasted, some of it, if it's too low, will be restricting the growth. So you haven't got a steady situation. Okay. So let's have a look at the rationing system. We're not going to do it, we're just going to look at it. The metabolizable protein system, so it's like the metabolizable energy system. This requires us to know about the metabolizable energy, because you can only utilize the protein effectively, or the cow can only utilize the protein effectively if it's matched by the right amount of energy. So we need to know how much energy is available, and for that a fermentable metabolizable energy is calculated. So this takes away fermented feeds that have already been fermented, like brewer's grains. Well, no, yeah, silage has already been fermented, I know, but I'm pretty sure that's not subtracted here. And it takes away the metabolizable energy in fat as well. So the fat comes from, the fat which you have in milk comes from two sources. Comes from the feed, and then about 50% of the fat in the milk comes from animal losing body fat herself. De novo synthesis of fats. And then it divides the rumen degradable nitrogen into a quickly and a slowly degraded function. And it says that of the quickly degraded nitrogen, only 80% of it is available. So some of the rest of it is wasted. There's too much nitrogen. Then it includes a calculation of the digested undegraded nitrogen. So this is nitrogen which is not degraded in the rumen, but it is degraded in the small intestine. So this has to be added as well. And it says that we have to, from that undegraded nitrogen, we have to take away the acid detergent insoluble nitrogen, nitrogen which is insoluble, which will not be digested at all, goes straight through the animal. And in some products, like the brewer's grains, you can have a lot of acid detergent insoluble nitrogen. If it's overheated in particular, if it's gone a brown color, then you're going to get a lot of waste of the nitrogen. It may look all right. Okay, so that's the theory of the metabolizable protein system. This is the actual representation of the system from AFR, from the Food Research Council. This just puts it into pictures. That we have the foods, the carbohydrate content is important, the crude protein. Some of that is undegraded dietary protein, but some of it is rumen degraded, producing rumen microbial nitrogen. Remember, the fermentable energy content is important in affecting that process. And then we have the rumen microbial nitrogen substrates leading to rumen true protein. Add to that the undegraded dietary protein and you get your total metabolizable protein. Okay, the metabolizable protein. Now if we were to subtract from that our urinary protein, we would get our net protein, but we work essentially on a metabolizable protein basis. And then the waste product is the fecal nitrogen, some of it coming from the rumen and some of it coming from the small intestine. So that is simply the metabolizable protein system. Okay, and just to give you the same thing effectively, okay, here's our crude protein intake with slowly degraded and quickly degraded, okay, leading to our microbial N substrates, some of it going out in the urine as urea, and then we've got our rumen undegraded protein contributing to fecal N and to the metabolizable protein. But what I wanted to emphasize here is that the protein is used for milk production, for growth, endogenous nitrogen secretions as well. There's a lot of cells in the urine and in the feces they're sloughed off from the gastrointestinal tract. There's some in the milk as well. They're coming from the mammary gland. That's the endogenous nitrogenous secretions. And then in the hair and for milk and for pregnancy. So that again is the MP system. Nearly there. So that just puts figures on it. And that's really all I wanted to say about the protein rationing. Anyone, any questions? Any questions? Any thoughts? Has anyone worked with the system? Anyone tried it out? It would be calculated mainly by computers, but the feed consultants, they'll be using it. Okay, well, if we don't have any questions, we're going to move on to our slides, our PowerPoint, which is going, our next section is on measuring nutritional welfare. Okay, and tomorrow we're having a debate on nutrition. Is it adequate for feeding animals and people? Okay, so I'm going to talk a little bit. I talk far too much, but I'm just going to talk a little bit more, and then Uttara Kennedy is going to use some practical examples of what we're talking about. Could we have the projector on, the data projector? It'll take a minute or two. There we go. Here we go. Good. So what we're dealing with in this session is practical measurement of nutrition and welfare. It was supposed to follow an earlier session when I'd been describing nutrition of the different species, and then we come on to consider, okay, how can we measure it? But we got a bit distracted. Okay, thanks, you two. Good, good. Okay, now, probably many of you have heard of the 5 freedoms, have you? How many people have heard of the 5 freedoms? A few, yes, okay. Well, let's just run through them. Stan. We've got freedom from hunger or thirst, freedom from discomfort, freedom from pain, injury, or disease, freedom to express normal behavior, most normal behavior it's usually called, and freedom from fear and distress. And this is really just telling you that every one of these is affected by poor nutrition. It's not just freedom from hunger or thirst. And in an earlier lecture, some of you won't have been here, but I did outline that hunger is not the only response to undernutrition or malnutrition. Hunger is the start of the process, but it will be followed by stress and lethargy, and we've talked all about that. So some people criticize the 5 freedoms because of that. It's not just about hunger. Freedom from discomfort. Obviously, aspects of malnutrition can lead to discomfort. Bloating, acidosis, I'm sure is very uncomfortable for the animal. Ketosis, mineral deficiencies. We know that an animal will very keenly assess sodium availability and will search for more sodium. So we can assume that it's not feeling good when it's short of sodium. Okay, and some diseases have a lot of relationships to malnutrition. Lame cows, for instance, they very often they can't get to the feed. They become very thin. So there are, even when the disease itself is not caused by malnutrition, it may cause malnutrition itself. Freedom from pain, malnutrition, and aggression between animals fighting for food, animals fighting for protein, for instance. We know they do that, can lead to injury. To express normal behavior, most normal behavior, well, a lot of feeds are unsuitable feeds for animals, too concentrated often. And so animals are not able to perform normal behavior, normal feeding behavior. I've talked about cattle that normally, when they're out at pasture, they will be consuming about 40,000 bites of grass every day. If we stop them doing that by giving them concentrated feed inside, then they're not able to perform their normal behavior. They start performing stereotyped abnormal behaviors, tongue rolling, licking their bars, things like that. And then freedom from fear and distress. A lot of the aggression associated with feeding can make some animals afraid. So all of these 5 freedoms are related to nutrition. But we do have to consider what measures we would use when measuring the welfare of animals in very large numbers. So what happens when we go into a battery cage system and we think the feeding is not good? What are we measuring? You know, we've got maybe 2,000 animals in here. Or if you're on a ship, when you've got 80,000 sheep, and if you're the vet or the agriculturalist looking after those sheep, what are you going to measure? It may be you'll be looking for thin animals, particularly around the rumens, so you can measure hollow rumens. But it takes a trained eye to do that. And the same with chickens. What are you going to measure? Because often the first thing that you are aware of from the point of view of a welfare problem is that you've got dead animals in the cage. So you want to try and get it before that. So how do we assess welfare of very extensive groups? If we consider the battery-caged hen in relation to hunger and thirst, we might say that they're probably not, for the most part, they're not hungry, they're not thirsty, but it's possible that there is metabolic hunger because they're short of calcium, quite likely. Why have we lost that? That's a problem at the projector and the data projector. Thank you. I don't know what happened. So that first one, hunger and thirst, for big numbers is important. And again, how do we assess welfare of meat chickens being raised in barns? Well, one thing we can look at is whether the chickens can reach the food. So the food is in troughs which are hung down from the ceiling. They're in containers that are hung down from the ceiling, and if the chickens can't reach those, they may die. Sometimes they will hop onto the backs of other chickens to try and reach the food. But leg problems is a big issue. Okay, so what are we looking for in relation to hunger and thirst? We're looking for the metabolic needs of the animal. We've talked quite a lot about metabolic needs today, the needs for milk production. We're looking at the gut's physiological requirements and whether the animal can eat what we intend it to eat. Has it got the appetite for a low-quality forage, for example? We're also looking for the feed to be palatable. We can measure feed palatability from the animal's rate of intake. If it eats it very fast, we say it's a palatable food. And then we also need to look at the animal's body condition as one of the most direct measures. We've talked about that quite a bit through the course. So that's the 5 freedoms. I'd also mention that animal welfare assessment has moved one stage further a little bit perhaps and moved towards what we call a 5 domains model. This has come out of New Zealand and it's somewhat similar, but I think there's a bit more thought has gone into it compared with the 5 freedoms. The 5 freedoms were developed by, well, they came out of the Bramble Committee in 1965, long time ago, when calf production for veal in the United Kingdom was being criticized by the public. So it goes back a long, long time, 1965, and the Bramble Committee was set to investigate calf rearing in England, and they said there were 5 problems, and they're pretty much what you saw in the 5 freedoms. And it's taken another 50 years before we have the 5 domains, which is similar. So nutrition is one of them. It's water deprivation, feed deprivation, and malnutrition. That's much better than just saying hunger and thirst. Much more accurate. Then it's the environment, health, and behavior, the same as before. But these all feed into the mental components, of which thirst and hunger may be some of those. So the mental components are saying, okay, what really matters from the animal's welfare point of view is what the animal feels in here. Does she feel happy or does she feel sad? So it is a more accurate model and is increasingly being used to evaluate welfare. We can also take an epidemiological approach to welfare assessment, and that leads me into the work that Jutta has been doing in assessing welfare in Goshalas, because that was the approach taken there. So in the epidemiological approach, we need to have a representative cross-section of the animals, and it's important to say, well, how are we going to select those? Or in the case of an assessment of Goshalas, a representative cross-section of Goshalas across India or across specific states. So that's a really important consideration. Are the animals which are being assessed from a welfare point of view, are they representative? If you go into a battery cage unit, are you looking at just the sick animals, or are you looking at an average animal? It may be a random selection of animals in a group, or you may have a targeted assessment. And then in that group of animals, you'd be assessing both the severity and the duration of a problem. So say cattle are getting lame. We need to know how long they're lame for and how severe it is. Or it could be mastitis. How severe is the mastitis causing pain to the animal? That leads us to develop incidences and prevalences. Have you come across those? Some of you will have done, I'm sure. So an incidence is the number of animals which are afflicted by a disease per year. The prevalence is at any one point in time. An important distinction if you're reading about that. So when we look for indicators of animal welfare, they may be input indicators or output indicators. So the inputs are all about the resources that the animal has, the buildings, the environment, the type of animal it is. The animal's genotype is really a resource input, and the type of stock person as well. How much experience have they had with the animals? Have they been trained or not? Both important. And then we've got the output variables, such as body lesions, bruising, we've got lameness and hock lesions. These will all be animal-based measures, and it might be, heart rate, respiratory function, a whole range of animal measures that can be taken. So particularly in input assessment, we might look at provision of food and water. And also under stock people as well. A caring stock person, we know, is extracting more milk from the cows. And that may just be that he's providing a bit more food and water, but we know there is a direct correlation between the personality of the person looking after the animals and the output. And in the case of dairy farmers, it's been shown that the highest output comes from stock people that are extroverts but careful. Attention to detail, very important. And then the output assessment might assess on the live animal or the dead animal, and that could be body condition score. It could be grading of the carcass. We've lost that again. Grading of the carcass, seen a lot of developments there in terms of use of video imaging. This one's all right. Okay. I suspect it's my computer. Okay, so just to conclude, nutritional adequacy can be assessed by the 5 freedoms. They're all affected by poor nutrition. And then we also have the 5 domains model, which includes a recognition of the animal's mental state. We can take an epidemiological approach to animal welfare. That's appropriate if we're doing big population studies. You know, not just assessing one animal, but doing a big population. And then both input and output measures are usable and important. There has been a bit of a focus in recent years on moving only to output measures, only animal-based measures. But they're very, very difficult to be sure that they're accurate sometimes, and difficult to take. If an assessor is going onto a farm just for a few hours to do animal-based measures is very hard. Needs to start looking at the buildings, what food is available. Okay, so I'll hand over to Yutura, who's going to tell you about the work she's been doing in Goshalas. And you might want to put that on, Yutura, if you can. And Yutura sent me a slide, so just pull those up.
Yeah.
Do you want to stand up in front?
Yeah, I think I will. Or I might. Do you want to swap?
You want to stand or sit?
Yeah. I think I'll have to stand because they may not see me. Okay, so I'm just going to talk about like what Clive mentioned was the theory of how you would go about assessing welfare, and then we converted that into practice. I did it for my master's dissertation, and we tried to create a welfare assessment protocol which we can take to a Goshala, get some measurements, evaluate it, get some results, and then do something with the results. So I'm just going to talk about the process of how we designed that particular protocol and the kind of questions you would need to answer if you wanted to go and design some kind of welfare assessment for people. So this is just one of the Goshalas. So what we wanted to do was we wanted to design a protocol. We needed to make sure that the protocol can actually be done in a reasonable amount of time, especially if you're going to do multiple Goshalas or multiple dairies or multiple farms. You need to be able to do it in 1 day or 2 days or whatever amount of time you've been given. We needed to make sure that it can be replicated between institutions. So many of the Goshalas were very different. Some had 8,000 animals, some had 200 animals, and we needed to make sure that the protocol is applicable to both. We needed to make sure that in the future, if somebody else, say 5 years later, wanted to use the same protocol, it should be replicable and it should give similar results using the same kind of methods. Obviously, it should be scientifically valid to have any meaning at all. And we decided, Clive said that a lot of protocols only look at animals, they don't look at anything else. And we decided that we wanted it to be holistic, so we wanted to look at the animal, at the environment it's living in, and also look at the human-animal interaction that's going on in the Goshalas. Yeah. So for example, the stock people, the people who are actually handling the animals, what their attitudes are. I'll go in a little more detail with that, but what their attitudes are, what their skill levels are, you know, what the managers think, what the trustees think, how much finance there is. Yeah. Yes. So anything that the animal responds to or reacts to would come in looking at that animal. So for example, looking at flight distance. So, you know, how close you can get to it until it runs away, or how afraid it is of you. That comes under the output because that's an output. So again, this is just examples of what we did. Here we're looking at the environment. I'm measuring the gradient of the floor. Here we're looking at the human-animal interaction. So we're actually this photo, the middle photo, is us talking to community members, but we did a similar thing talking to the managers and to the staff who actually work in the Gaushala, asking them a whole lot of questions. This is actually a project, it's a PhD project of my colleague Arvind Sharma. So we did it in collaboration. So I took up a part of it for my project, and he took up a part of it for his PhD. And then, of course, we looked at the animals as well, themselves. So we needed to work out how exactly we're going to do this, what we're going to do in the one day. We decided we were going to do it within one day at each Gaushala. So we needed to work out how much time, what exactly we can manage to measure in just that 8 hours is something that we get. So we needed to divide the 8 hours into looking at a certain number of animals, looking at features of a shed or a housing facility, and also leaving time to talk to the owners. We needed to work out what do we want at the end. Do we want to be able to go back to the Gaushala managers and give them some kind of quantitative result and say, look, this is where you need to improve. In our own project, we actually wanted to validate our protocol. So we wanted to make sure that if you relate animal-based measures with resource-based measures, you do still get the same result. So for example, if you work out that a floor is really bad for cow's hooves, then you should see that level of lameness on that floor. And we had to work out how to select our samples. So there were some Gaushalas which had 30 sheds, and some which just had one shed. And like I said, some which had 8,000 animals, some which had 100 or 50. And we had to, through a lot of discussion, we worked out how many sheds would be our sample. So we decided in this study, we looked at a minimum of 2 sheds and 30 animals in each organization. And just to talk about why would we measure welfare, besides it being good for the animals, obviously, one of our aims was that through having a protocol and through it being used in many Gaushalas, we would ultimately be able to work out some minimum standards, which are very necessary. Once you have minimum standards, you can use those standards to score a farm or a Gaushala or any kind of institution. And I'll talk a little bit more about one way that you can do scoring. You can take that score back to a Gaushala manager and say, look, this is your score. You've scored well in this part and not in this part. And they can take that and they can assess themselves year after year. They can go back to their board of trustees and say, this is our assessment. This is where we've improved. And of course, if they don't want to do it themselves, maybe the government or a private organization, Khushbu was talking about getting something like that started in India, can go in and do an external audit for them. And this is one example which is happening in Australia. The RSPCA has a certification scheme. So they go out to farms, they conduct their audits, they do a welfare assessment protocol, and they work out if that farm is meeting their standards. And if they are, then they get a stamp, and the consumer knows that they're getting good welfare products when they're buying eggs or milk or whatever. So this is just an example. We measured a lot more than this, but in input, so we took input and output. In input, you would consider the environment. So for the environment, we measured all kinds of things: type of housing, flooring, ventilation, what feed was given, how many times the feed was given, whether the water was given ad lib. And we also questioned animal managers. So we asked them about their attitude towards animals, how much study they had done, if any, how much money was put into the Gaushalas and how it was calculated, things like that. And then Arvind looked at the output, which is looking directly at the animal. So he had a whole bunch of parameters that he looked at. And you can also look at health records for things like mortality rates. Most of the Gaushalas we visited didn't have health records. So we couldn't do this, but other industries probably would have better health records. And this is just an example. We haven't done this because we are still, Arvind is still in the middle of his PhD, but this is an example of how you can do something with the results. So you get all your parameters, and then depending on what score they got, they get grouped into red, orange, or green. And then you get a table like this. So for example, if you're looking at lameness, you work out what score gets green, orange, and red. And same with BCS, Hock lesions, cleanliness scores, flight distance, lying behavior. These are all animal-based measures, so they're all output. And it's just an example, and this is completely hypothetical. If they got these kind of scores, that is in the middle there, it's going to go off.
Top right. Top right.
So if you get these middle scores, that's the color you get at the end. And you can, I've made up these numbers, they're not real numbers. You can take this back to a Goshala manager and say, look, you got 2 reds, 2 greens, and 2 oranges. You can work on the areas which need improvement. So that's just an example of how you can use a welfare assessment. And that's it.
Thank you.
Yeah. Oh, I should leave this on. Yeah.
A lot of dairies would have a milking cow section.
Yes.
A lot of goshalas would have a milking cow section.
Yeah.
So do you include or exclude those animals in your sample?
So it depends on how you design the protocol. In our particular design, we chose to exclude it. So we were looking at only non-productive animals. But if you had a protocol, you could actually design it to look at different types of herds, and you would modify the protocol accordingly. So you would have, certain measures which you looked at in dry cows, certain measures in calves, certain in bulls, certain in lactating animals, and you would use that depending on what kind of herds the Goshala had.
There's an increasing trend of opening dairies and then calling them gaushalas in India, because gaushala, literally, if you translate it, it means a cow for a home, for a cow. So they say that just because it's a dairy and the cow stays there, it can be called as a gaushala. So when you do that, how do you define gaushalas in your project?
Yeah. So we found that depending on which state you're looking at, the terminology was different. So in Gujarat, for example, a true shelter was called a panjra-pole, and a dairy was called a gaushala. And it was well known. Whoever you asked, they said, oh, gaushala, of course, that's commercial. Whereas in Himachal Pradesh, for example, gaushala is a true shelter. That's what Arvind found out. So, and we found this when we did a pilot study. And so we had a lot of discussions about how we're going to define it for our particular study. And we came up with a few criteria. But that criteria could change depending on who's doing it and for what purpose they're doing it. So we had a minimum number of cows that were non-productive. We had a criteria for where those cows were sourced. We had a criteria for how the place was funded, things like that. Yeah.
हिमाचल में कौन सी गौशाला?
बहुत सारी की अभी तक स्टडी चालू है, तो अभी तक फिनिश नहीं हुआ है, लेकिन जो अरविंद शर्मा है मेरे कॉलीग, वो हिमाचल से है, तो उन्होंने शायद 20-25 उधर की होगी. हाँ, लेकिन वो अभी वापस आए हैं, तो अभी डेटा सब रिजल्ट्स अभी तक हमने एनालाइज नहीं किया है.
अगर उनका मेल एड्रेस मुझे,
या अरविंद्स ईमेल एड्रेस, ही लाइक इट.
क्या ये गौशालाओं के लिए कोई सर्टिफिकेशन सिस्टम है कुछ?
नो. इसीलिए हम ये मेहनत कर रहे हैं कि फ्यूचर में अगर लोग ये स्टडी को और ले जाए और ऐसे प्रोटोकॉल बनाए, तो प्रोटोकॉल लेके फिर सर्टिफिकेशन सिस्टम हो सकता है. अभी तो कुछ भी नहीं है. We did, for our study we did, because you have to limit it. We had a set amount of time and we couldn't go on doing it. And our purpose was not so much to assess the Goshala, our purpose was to build a protocol and to validate it. So for that we needed a fixed sample.
Is there this program or welfare program for this organized dairy sector? Is there any certification for them? What is the welfare for the animals?
For which dairy sector?
Organized dairy sector.
I don't think there is. And so there are NGOs like World Animal Protection working towards getting a minimum standard set. But Khushbu can talk to you more about that. But
Yeah, on dairies.
What about commercial?
Commercial dairies.
Commercial as well.
Yeah, only commercial dairies. Dairy is something which has been set up for commercial purpose only. It has not been set up for non-commercial.
But Gaushala
Gaushalas are supposed to be just working for the old, infirm and spent cattle, but it's now changing in the modern world. I'm also interested to know, like, during your field visits, especially, you must have observed manufacturing of value-added products from the cow waste, dung and urine. So, I have seen some gaushalas where the welfare of animals, like if I just look at the parameters that you have used, was severely compromised, even though they were not dealing really in milk, but because of the money that they were getting because of these products. So, what was your observation? Did you still consider them as gaushalas?
We did. So if they were, for example, if they were selling their dung, that's a commercial activity. But we didn't pay attention to that.
I actually visited once in Uttar Pradesh. I visited a gaushala where all the cows were put in the basement. There was a house which was built in the basement with no ventilation and just like a steep ramp. And the rest of the gaushala premises was used for training people, housing people and trainees, to teach them how to make products from urine and dung.
Have you got your slides here, Khushbu? Have you got your slides here?
No,
कहाँ
I
देखा था
haven't
मैडम ये?
computer today.
यूपी में
UP में.
मैं भी स्मॉल लेवल पर इसी लेवल पे बना रहा हूँ बेसमेंट में हाउस
Oh no, don't do that. He's planning to put his cows in basement.
no I'm dealing with 7 or 10 cows
No, even for one cow.
मैडम एक बात मैं
Even for one cow.
पुराने टाइम में हिमाचल में हिली एरियाज में जितनी भी गाय थी वो बेसमेंट में ही रखी जाती थी मकान होते थे लकड़ी के या
Traditionally, they always kept
basement
cows
में
underground in
एक
those
तो क्या
regions.
था कि वो इंडियन ब्रीड थी और मतलब कि उसका स्मेल वगैरह ज़्यादा नहीं होती थी काऊ यूरिन की नंबर 2 उसकी वजह से कमरे मकान गर्म रहते थे और नंबर 3 इजी बर्फों में कैसे उस तक पहुंचना है गाय तक
But अब तो
वो
situation
अंदर से ही
change
उसके
हो
लिए
गया.
रास्ता होता था अभी भी बहुत से घरों में है एरिया में
लेकिन आप तो मॉडर्न कंस्ट्रक्शन कर रहे हैं, तो आपके पास चॉइस है.
नहीं
कि
आपके
ऐसा करें
पास
जो
हिली
high welfare
एरिया में आपके पास स्पेस ही बहुत कम है एक तो स्पेस बड़ा कम है एक कॉस्ट ऑफ कंस्ट्रक्शन बड़ी कम है आप एक शेड बनाएंगे पहले काउस के लिए फिर आप स्टाफ के लिए बनाएंगे फिर आप ट्रेनिंग्स वगैरह के लिए बनाएंगे या स्टोर बनाएंगे वो सारी रूफिंग कंस्ट्रक्शन जो है वो तो उसी बराबर पड़ जाएगी उसके बजाय मल्टी स्टोरी बनाकर
He's saying in order to save the cost on building a cow facility, like you just put animals and everything in the basement so that the roofing cost is taken care of.
Is it also the heat?
Yes. So he said traditionally it was used like that. But now he's thinking of multi-story structure. Where you could put animals in basement and people.
I think
और जनरली हमारे यहाँ जो कहते हैं कि डे टाइम में हम बाहर निकालते हैं गर्मियों में सुबह शाम बाहर निकालेंगे दिन में अगर हम निकालेंगे तो उनको मक्खियाँ तंग
So,
करेंगी.
सर ये भी सर बोल रहे हैं कि मतलब अगर आप वहाँ मतलब कहीं पे भी आप रखते हैं अपने कैटल को, लेकिन आपको ये ध्यान रखना चाहिए कि आप उन्हें 24 घंटा वहाँ बांध के नहीं रखना है.
नहीं
तो वो पूरा उनको
और वेंटिलेशन है वहाँ लाइट सिस्टम है वहाँ और क्या है कि सुबह हम जनरली बाहर निकाल देते हैं डे टाइम में मक्खियाँ तंग करती हैं तो उनको अंदर कर देते हैं और थोड़ा सा अंधेरा रखते हैं और शाम इवनिंग टाइम में फिर उनको बाहर निकाल देते हैं या थोड़ा ग्रेजिंग पीरियड है उनका 2 घंटे ग्रेजिंग पीरियड है.
Because they say they get fly.
Yeah.
but whole afternoon without any light in the basement.
लेकिन वहाँ ओपन स्पेस नहीं है ज़्यादा उसको लेवल करने में ही हमारी कॉस्ट बड़ी पड़ जाती है.
Maybe you can get a biogas system to produce electricity and light.
नहीं रूरल एरिया में कोई
No, you're saying that it's because there's a lot of
Flies, yeah.
so that's why there is
एक्सपेंसिव
You can't win.
पहाड़ी को काटना है वहाँ से आगे पहाड़ी वहाँ से मैं कटिंग करना शुरू करूँगा
तो पोस्ट तो बहुत ज़्यादा बढ़ जाती है, अलग अलग शेड्स बनाना इतना स्पेस ही नहीं होता हमारे।
नहीं उतना नहीं, बट विद इन आपके जो कंस्ट्रेंट्स हैं हिली एरियाज में, उसमें कैसे एक हाई वेलफेयर सिस्टम डेवलप कर सकते हैं, वही तो चैलेंज है। क्योंकि लो वेलफेयर में तो मोस्टली लोग कर ही रहे हैं, तो आप उसका
नहीं,
एक
उसमें मैं तो कहता हूँ ना कि आप लोग कभी आइए, स्टडी करिए, क्या मेरी कमी है मुझे वो बताइए।
वो डॉक्टर शर्मा है ना, वो हिली एरिया से ही है, उन्हें जानकारी होगी, उनसे बात करिए। डॉक्टर अरविंद शर्मा।
पर वो तो
नहीं वो वापस आ जाएंगे।
हाँ, मैं कॉन्टेक्ट में रहूँगा, मैं कुछ और लोगों के पालों को जाना चाहता हूँ, मैं
Because he is in
कॉन्टेक्ट
from
में रहना
hilly
चाहता
areas
हूँ।
and he understands welfare. He will be able to advise.
Yeah.
So if there is proper ventilation and there is artificial lighting system, so is this still problem in the basement?
Yeah, if housed permanently, what he's saying that permanent housing.
No problem.
Not permanent.
They
Yeah.
can take it and they can
Just
take it out.
just
Bring it in the morning for 2 hours, and for 2 hours we are bringing them for the grazing.
The problem is only
For 2-3 hours in the evening.
Yeah.
They are.
Yeah, if they're there for morning,
So
evening,
that's better.
sometimes just to sleep at night, then it's still okay, but there should be some ventilation.
Ventilation and windows and
The one I had seen was like constitution.
Windows is probably not enough.
Yeah.
You need more space.
And I think once you get into an animal house, you may get to know.
Want to stay and chat, I'm sure would be very welcome to do so. But thanks very much to everyone for coming today. Tomorrow we're going to have a free and liberal debate on nutrition and feeding cows, feeding animals, and bring your questions and your minds to chat about things. It's the end of the course, so it'll be more relaxed. I think today was a heavy day on rationing, and tomorrow would be more for discussion. I think I'll lead the discussion and have a few thoughts, and it'll be very broad-ranging. So be prepared for a very broad discussion. Thank you for coming today.